Lesson 48 useState. 1. Introduction. Good morning, afternoon everyone. Today I'm going to walk you through how to introduce and work with the concept of state variables in React, in particular via the mechanism known as useState. This is a key building block when you're creating interactive components. 2. What is useState? At a high level, useState is a special function, often called a hook, provided by React that allows you to add a state variable to a component. By state, we mean a piece of data that influences what the component renders, and which can change over time in response to user actions or other events. When you use useState, you declare a state variable and a corresponding function to update it. 3. How useState works. When you invoke useState, you pass in an initial value. React will store that value internally and, on the first render, your state variable will hold that initial value. Alongside that you get a function which you call when you want to change the state. When you call that update function, you request that React re-render the component, and its children, with the updated state value. 4. Rules and conventions. There are some important conventions and rules when using useState. First, you should call useState at the top level of your component or custom hook, not inside loops, conditions or nested functions. The reason is that React uses the order of hook calls to track state across renders. Second, by convention the state variable and its updater are named in a paired fashion. For example, you might name the state, count, and the updater, setCount. This makes it clear what gets updated. 5. Updating state based on previous state. Sometimes the new state value depends on the previous one, for example, incrementing a counter. In that case you must be mindful. If you simply reference the previous value and calculate outside of React's update mechanism, you may encounter stale values or unexpected results. React allows you to pass an updater function which receives the current value and returns the next value. Using that pattern helps ensure your updates are correct even when multiple updates are queued. 6. Complex state values, objects and arrays. State need not be a simple primitive like a number or string. You can store arrays or objects in state. The key thing here, you should avoid mutating the existing object or array. Instead, you should create a new object, array representing the updated state. React only triggers a re-render when it finds that the new state value is different from the previous one, in terms of identity or equivalence. If you mutate in place and then pass the mutated value, React may skip the update because it thinks nothing changed. 7. Lazy initialization and performance considerations. When the initial state requires a heavy computation, for example building a large array or computing an expensive default, you do not want that computation to run on every render. React supports a pattern where you provide a function that returns the initial state. That function is only executed once, on the initial render, rather than on every render. This helps keep your components efficient. 8. Resetting state via component key or remounting. Sometimes you want to reset the entire component's state to its initial configuration, for example when you want to start fresh or clear user inputs. React supports patterns, for example via changing a key prop on the component, so that the component is remounted, thereby resetting all its internal state. This is a more structural way to reset state rather than manually resetting each individual variable. 9. Storing information from previous renders. A more advanced pattern. You might want to record what the state or props were on previous renders, for example to display previous value was, or to detect change direction. You can use state for that. When a new render happens you compare the previous value you stored to the current prop or state, update accordingly, and then render based on the comparison. It's a little more advanced and must be used carefully, for example to avoid infinite loops. 10. Troubleshooting common pitfalls. There are several common pitfalls when working with useState. If you call the updater function and then immediately try to read the state in the same render, you'll still see the old value. The update takes effect in the next render, not immediately in your current code. If you mutate state in place, objects or arrays, and pass that back, React may detect no change and skip the render, so the UI seems unupdated. If you set state unconditionally during render, rather than in an event handler or effect, you may create a loop of re-renders which leads to an error like too many re-renders. In development mode with strict mode, React may invoke your initializer or updater functions twice to help you detect impure logic, functions that cause side effects or depend on external state. Be sure your initialization and updates are pure, no side effects, to avoid unexpected results. 11. Summary and key takeaways. useState is the primary way to add local state to a React functional component. It returns a pair, the current state value and the updater function. Use the updater function to change state and trigger re-renders. When the next state depends on the previous state, prefer the updater function form. For arrays, objects, replace rather than mutate. Use lazy initialization when computing the initial state is expensive. Avoid triggering state updates in the body of the component in a way that causes infinite loops. Use reset patterns or remounting only when you truly want to start fresh. 12. Closing. I hope this gives you a clear conceptual understanding of how useState works in React, how to apply it properly, and how to avoid common mistakes. In our next session, we can walk through practical examples, explore more advanced patterns and hooks, and see how state interacts with effects and context.